Welcome to part 2 of the C2 development series. In the previous part, we implemented listening functionality and our server can now accept new connections. But once we receive a new connection, we don't really use it and we don't store it anywhere, we just print a message to the user. In order to manage multiple sessions, we need to store every new connection object we receive from the server somewhere. And this is going to be the purpose of this video. We will implement a new type that will be responsible for storing and managing sessions. So I will create a new file and I will call it sessionmanager.go. Let's define our type. I'll call it session manager. And here we are going to declare a slice in which we are going to store the new connections. Also, because functions in this type will be called concurrently, we will need a mutex to lock access to the slice whenever interacting with its data. This will prevent race conditions by ensuring that only one coroutine can modify the slice at a time. Those are the two fields we are going to need for this type. Now let's implement a method for adding a new session. Here we will need a parameter of type net.con. Remember that the server, when listening over here, will actually return this net.con type when accepting a new connection. So when the server receives a new connection, it is going to supply it to this session manager and it is going to store it in this slice here. Let's implement it. Notice how I am acquiring the lock before performing the critical operation of adding the new connection to our slice. As I said, the goal of this is to prevent race conditions and unexpected behaviors. Now let's implement a method for removing a session. As a parameter, we again take the connection that we want to remove. The logic for removing an element of the slice goes as follows. We are going to iterate over all connections in the slice and we are going to look for a connection that matches the parameter that was sent here. And when we find it, we are going to remove it with this line here. Finally, once the connection is removed from the slice, let's close it. And of course, to prevent race condition bugs, it is very important to acquire the lock before performing this action and release it after performing it. Now we can use our type to add and remove sessions. Let's implement a few other helpful methods. First, a method that returns the session count. It will return an integer, which will be the count of the sessions. Of course, this is also a critical part of the code where we are interacting with the data in this slice. So let's make sure it is thread safe. Let's implement another method that returns a connection given an ID. An ID is simply the index of the element in this slice. We take an integer as a parameter, which is the ID, and we return a connection object. And we can simply return the connection that is at the index of the ID. Let's make it thread safe. Finally, let's create a method that returns all active sessions. And it will return a slice of connections. Here, in order to follow the encapsulation principle, I am not going to return a direct reference to the connection slice. Instead, I am going to return a new copy. The reason for that is we want to keep all interaction with the slice within this object. Sending a reference of our slice outside of the object allows for external modification of the data, which breaks the encapsulation principle and could introduce race conditions because the mutex in this object will no longer protect the data. And of course, let's make it thread safe. We have now implemented a couple of very useful methods in this type. Let's now try and use it to store the new connections that we receive from our server. Just like with our server type, we are going to create a new instance of our session manager type again in the main function. Now, where is the place that our server sends new connections? It is to this channel. And where is the place that we handle these new connections? It is in the handler function. So the new connection handler function is going to be the place where we need to add new sessions to our session manager. Let's add it as a parameter. And here, before we print our message, we simply need to add this connection that we received to the session manager. Now we need to pass our session manager instance to this function from the main function. I'll actually place it above our handler call, and let's pass it right here. Now all our new connections should be added to our session manager. But we can't really check yet because we haven't yet implemented our sessions functionality. Remember that this is the command that is going to display all active sessions. So let's actually implement this command now. I'm going to create a new function for it. Of course, when working with sessions, we need our session manager instance. From now on, whenever we need to interact with our sessions, we're always going to be doing it via our new type, the session manager. So now let's use some of the methods that we implemented earlier. If the sessions are less or equal to 0, we print that there are no sessions active. And we return from the function. We'll reach this code here only if there are some connections in our session manager. First, let's retrieve them from the session manager. Remember that this returns a slice of connections, so let's iterate over it and print them to the user. And we print them to the user in the following way. First we have the ID, which is simply the index of our connection in the slice. And then we use this remote ADDR function to display to the user from where the client has connected. Notice that here we don't need to worry about thread safety at all. All of that is managed in our session manager object. Okay, now let's call this function if the user inputs the session command. And let's pass our session manager instance right here. Let's now test what we have done. I will run the server. Let's try to list the sessions. We see that no sessions are available. Let's connect a client. A connection has popped up. Let's check the sessions now, and as you can see, the new session has appeared. Let's connect another client. And there we go. We have 2 sessions now. Now what happens if I close one of the sessions? As you can see, the server is not recognizing that, and it is not removing the session from this list. This is something we also need to implement. We need to somehow check if the connection is alive or not. We will do this in the next episode.